So the condition we have that a n sub 1 is equal to b n sub 2. These numbers will be different. These two sequences will not have the same value at the same position. So that's why I'm calling them n1 and n2. So that means that this is 13 plus 6. That's our condition. So first I'm looking for what that relationship is between those specific positions. N2 minus 1, and I can distribute that. 6n1 minus 6, 7n2 minus 7. So that becomes 8 plus 7n2. This becomes 7 plus 6n1. And then subtract that. And then I'll isolate n1 and try to generate the integer values for which, essentially finding solutions to this where both n1 and n2 are integers. So I'll split that 7n2. So this is kind of a standard approach for these types of questions. So meaning you need to come in knowing that this is how you will go about it. You can't be figuring this out in the exam. So I've taken out the whole number part because I know this is integer, this is integer. So this has to be an integer. So if I make a table here, what's the least value of n2 positive would be 5, because then this would be 5 plus 1, 6, which is divisible by 6. This whole thing will become 1, and then n1 would be 6. And you can imagine, you can think of different values. For example, n2 next could be 11. So then it would be n1 would be 13, so on and so forth. So I need to find the largest 3-digit integer, meaning a number less than 1,000. So my condition is if I look at b sub n2, which is really 8 plus 7n2, has to be less than 1,000. So that will give me an upper limit on what n2 would be. So subtract 8, and then n2 has to be less than, to satisfy the condition that it has to be a 3-digit integer. So if I do this division, 7 times 1 is 7, 7 times 4 is 28. You can use a calculator here. 141.7. So n2 has to be less than 141. And now you'll see if this whole thing is 144, it is divisible by 6. I kind of already know that part, the 144 being divisible by 6. So the next number that's less than 144, that's divisible by 6, would be if I subtract 6. So I need this whole thing to be 138. So n2, the largest value that would still give me a 3-digit integer would be n2 would be 137. Note, this is 138. And you don't have to compute n1, but if you needed to, you could just do this. So it would be 160. So this is your n1 is 160. And then this is 137. And we can find that largest number. We didn't need to do this part here. By plugging it into this relationship, which is b n2, which is 8 plus 7n2. n2 here is 137, so you just plug that in. 959 plus 8, it's 967. And if you were to do it for n1 as well, which is really 7 plus 6n1, you'll get the same answer, because 160 times 6 is 960, and as it should, because that was the condition that both sequences are giving you the same number. So the answer is 967.